Hi friends, this is Venu from NRI Institute of Technology. In this session, let us learn about the linear programming with graphical method. As I have explained linear programming with graphical method for maximization in previous video. In this video, I am going to explain to find the minimum value, that is for the method of minimization. For the implementation steps, you can refer the previous video. Here I am going to explain only the example. And here I take the example as solve the following LPP by using graphical method for minimization. That is, here the objective function I have taken is z is equals to 40x1 plus 80x2, and the subjective conditions are 72x1 plus 12x2 is greater than or equal to 216, and 6x1 plus 24x2 greater than or equal to 72, 40x1 plus 20x2 greater than or equal to 200, where x1 and x2 are greater than or equal to 0, as x1 and x2 are non-negative constants. Let us solve this problem. Solution. Initially, we have to declare the objective function and the subject that was given in the problem. It is the objective function, it is the subjective. First, we have to convert the inequalities into equalities. That means the inequality equations as shown here, greater than or equal to, we have to modify these greater than or equal to into equalities. There is no any specific methods or process to make this. You can directly change the inequalities into equalities, and later find the coordinates of the equations. Let us name these equations as A, B and C. For equation A, that is 72x1 plus 12x2 is equals to 216. First, for finding x1, let x2 is equals to 0. Then you get 72x1 plus 0 is equals to 216. By solving it, you get x1 is equals to 0, and to find x2, let x1 is 0, then you get 12x2 is equals to 216. By solving it, you get x2 is equals to 18. Here you get two coordinates for equation A. That is, when you take x2 as 0, you get x3 as 3. A coordinate is 3 comma 0, and when you take x1 is equals to 0, you get x2 as 18. That is the second coordinate, that is 0 comma 18. And now solve equation B. Let x2 is equals to 0 for x1, finding of x1. Then the equation becomes 6x1 plus 0 equals to 72. By solving it, you get the value x1 is equals to 12. Here you get a coordinate, that is 12 and 0. And to get x2, let x1 is equals to 0. Then the equation becomes 24x2 is equals to 72. By solving it, you get x2 is equals to 3. Here you get an another coordinate of b, that is 0 comma 3. In the same process, let us solve the equation C also. That is, for finding of x1, let x2 is equals to 0. Then the equation becomes 40x1 plus 0 equal to 200. By solving it, you get the value of x1 is equals to 5. Here we get a coordinate of C, that is 5 comma 0. And for getting x1, x2, let x1 is equals to 0. Then the equation becomes 20x2 is equals to 200. By solving it, you get x2 is equals to 10. Here you get another coordinate of C, that is 0 comma 10. We have to make all these points to be placed in a graph as shown here. It is equation A, equation B and equation C. These are the coordinate points that have to place. For equation 72x1 plus 12x2 equal to 216, the coordinates are 0 comma 18 and 3 comma 0. And for equation B, the coordinates are 0 comma 10 and 5 comma 0. And same as like that, for equation C, the coordinates are 0 comma 3, 12 comma 0. Now you have to combine the coordinate points, corresponding coordinate points of the equation. Here we want to find the minimized value. That means we have to find the minimum value for of the feasible region. In previous video I have said what is feasible region. You can refer there. Here for minimum value, the area, that is the feasible region, lies outside the points, coordinate points, as it is the feasible region. The outside points coordinates are A, B, C, D, and now we have to find the coordinates of the feasible region, that is coordinates of A, B, C, D. By observing the graph, we can directly have A coordinates and D coordinates. That are, for A it is 0, 18, for D it is 12, 0. Then we have to calculate the coordinates of B and C. To find BC, let us solve the equation. You can take any two of three equations. Yes, initially you have given three equations. You can choose any two of them. By solving both two equations, you can get the point B and point C. I consider equation A and equation C. First, make sure that the coefficient of any one of the variable must be same before you are going to subtract the equation. Here I make the coordinates of x2 to make equal. For that I made multiplication with 5, and for C equation I multiplied it with 3. Then it becomes 360x1 plus 60x2 equal to 1080, and the C equation becomes 120x1 plus 60x2 is equals to 600. Now made a subtraction operation on both the equations. You will get 240x1 equal to 480. By solving it, you get x1 is equals to 2. Similarly, substitute. First, here we get x1 is equals to 2. Substitute this x1 value in C. Here I am taking C. You can substitute it in A also. By substituting x1 is equals to 2, we get 40 into 2 plus 20x2 is equals to 200. By solving it, we get the value of x2 is 6. Finally, we get the B coordinate, that is 2, 6. In the same process, calculate the coordinate of C by using C and B equations. And we have the four coordinates of feasible region, that are A, B, C, D. By placing these four coordinates in the objective function, you can find the minimum value as shown in the figure. For A coordinate, that is 0 and 18, take 0 and 18 in the place of x1 and x2. Then the value we get is 1440. And for B coordinates 2 and 6, place them in x1 and x2. Then we get the value 560. And C values 4, 2, place them in x1 and x2 place. By solving it, we get 320. And D coordinates 12, 0 are to be placed in the place of x1 and x2. By solving it, we get the Z value as 480. In this above four values, that is the outputs, the minimum value is 320. Hence, we get the minimum value as 320 at the point of 4, 2 ordinates. Thank you.